All right, what's up guys? In this video, we're gonna pick up some calculus here. It's gonna be another integration practice video. This will be example number 13, basically. So let's do it. So we want to evaluate the integral x times e to the 2x all over 2x plus 1 quantity squared dx. So if we look here, we need to identify the appropriate integration technique, and u substitution, that isn't going to work here. If we pick u to be 2x plus 1, that's not going to help us. Even picking u to be 2x plus 1 squared won't necessarily be helpful. Also, picking u to be 2x here for the e to the 2x, that wouldn't be helpful either. This definitely is not partial fractions. This is not a trig substitution. So it looks like we're going to have to go with a little integration by parts. So let's try that. And you have to do the process of elimination in your head when you're starting with some of these integrals. Just start going through the different integration techniques and asking yourself which can be used. So we'll use integration by parts. So that's the integral of u dv is equal to uv minus the integral of v du. So we know what we need. We need u and we need dv. So what would be appropriate u here? Okay. Well, in my opinion, the appropriate u would be x times e to the 2x. Now why? Well, remember, if dv is x times e to the 2x, remember to get v, we'd have to integrate x times e to the 2x, which will require integration by parts, well, a u substitution, and then we'd probably have to do by parts after that. So not a hard integral to evaluate, but a little too much work. And so if we pick this to be u, that's a lot easier to differentiate than to integrate, and just use the product rule for that. And so what we'll do is we'll pick u to be this, and that means that dv is just going to be 1 over all that stuff. So it's going to be 2x plus 1 quantity squared dx. So you just got to figure out what would be the best selection. So we now find du. That's the product rule, okay? So that means we'll have e to the 2x plus x multiplied by 2e to the 2x, and then multiplied by dx, because the derivative of e to the 2x is 2e to the 2x if we use the chain rule. And then we need v, so that's the antiderivative of 1 over 2x plus 1 quantity squared. And we can do a u substitution for that. So that's going to be u, that's 2x plus 1. Okay. We don't need to pick it to be 2x plus 1 squared. That is not necessary. And if we take the derivative here, obviously we'll just get 2 dx. And so we'll end up with 1 over 2 du is equal to dx. Okay. So 1/2 comes out front. And it looks like we'll have the integral of 1 over u squared du. The integral of 1 over u squared, that's negative 1 over u. And to validate that, remember, you can rewrite 1 over u squared as u to the negative second and integrate it that way, and you would still get negative 1 over u. So this would be 1/2 times negative 1 over u. And remember that u was 2x plus 1. So we'll have 1/2 negative 1 over 2x plus 1. Okay. And that gives us negative 1 over 2 multiplied by 2x plus 1. And you just add up basically a plus c. And that would actually be our v. So our v here, it's just going to be negative 1 over 2 times 2x plus 1. All right, so that's v. Okay, so now we got everything we need. So now we go to our integration by parts. So it looks like we'll have x times e to the 2x multiplied by negative 1 over 2 multiplied by 2x plus 1. And then we'll have a minus, we'll have the integral, looks like we'll have negative 1 over 2 multiplied by 2x plus 1. And then we'll multiply that by e to the 2x plus x times 2e to the 2x dx. Okay. And we begin by cleaning things up. Let's get another sheet. Should not need an extra one. I'll get one if we need it. All right. Remember, multiplication is commutative, so we can kind of clean up the left-hand side a little bit. So bring the negative to the side. And, well, we'll just write this as e to the 2x multiplied by x all over 2 times 2x plus 1. Now, this is going to be plus, and we're going to pull out a 1/2, and this will be the integral. It looks like we'll get the integral of e to the 2x dx. Okay, well, the integral of e to the 2x dx, that's just a u substitution. That's 1 over 2 e to the 2x. Okay, so now we just take that 1/2, multiply it by 1/2 e to the 2x, which gives us 1 over 4 e to the 2x. And then all we have to do is plug that back in to our integration by parts formula, and we'll get our answer. So this one wasn't that bad. So our final answer for this one, so the integral x times e to the 2x all over 2x plus 1 quantity squared. So we can write our answer as negative e to the 2x multiplied by x all over 2 multiplied by 2x plus 1. And this would be plus 1 over 4 e to the 2x plus c. And that's your answer. And that's how you do it. All right, so that was example number 13. So hopefully that made sense. All right, guys, I'll see y'all next time.